Okay, so question 4 from our revision session, which is the one that caused a bit of concern. Let's just go through this together. So you can see we've got our ball held in a clamp, currently with no velocity because it's held still, and it's dropped 3.8 meters, and we know that at the point of S, our momentum is 0.4 kilogram meters per second, and it's on planet Earth, so the acceleration due to gravity is 10 meters per second squared. The equation that you need to use for this is v squared minus u squared equals 2 times the acceleration times by the distance, which is given as x on our formula sheet. So now we've got to do some substituting some numbers in. So we don't know what v squared is. We don't know what the velocity is at point S. However, we do know what the velocity is at the beginning because it's not moving. So it's going to be 0 squared, which is going to be 0 obviously, and 2 times the acceleration, or we've got the acceleration due to gravity here, so that's going to be 10, and we also know the distance, it's this distance here, 3.8 meters. If we then plug all of this into our, and rearrange it all round, so we know that v squared is going to be 2 times 10 times 3.8, which gets the v squared equals 76. So therefore v is root of 76, which rounds to 8.1 meters per second. So that's the first part of our calculation. We then have to use the momentum that we've been given, which is this one here. So we know that momentum equals the mass multiplied by the velocity. We know momentum is 0.4. I'm trying to find mass, and we know the velocity at this point is 8.1 meters per second. So now we just need to rearrange all of this. So therefore the mass equals 0.4 divided by 8.1, giving us an answer of 0.0459, which I'm going to round to 0.0446 kilograms. Sorry, off the camera there. There we are. Okay, so that's the answer to question 4.